Let's talk about robots. Well, the time has come. The time has come for robots. Robots have the benefit of being able to interact with the physical world and do things that otherwise digital information cannot. We know very clearly that the world has severe shortage of human laborers, human workers. By the end of this decade, the world is going to be at least 50 million workers short. We'd be more than delighted to pay them each $50,000 to come to work. We're probably going to have to pay robots $50,000 a year to come to work. And so this is going to be a very, very large industry. There are all kinds of robotic systems. Your infrastructure will be robotic. Billions of cameras in warehouses and factories, 10, 20 million factories around the world. Every car is already a robot, as I mentioned earlier, and then now we're building general robots. Let me show you how we're doing that.
Everything that moves will be autonomous. Physical AI will embody robots of every kind, in every industry. 3 computers built by NVIDIA enable a continuous loop of robot AI simulation, training, testing, and real-world experience. Training robots requires huge volumes of data. Internet-scale data provides common sense and reasoning, but robots need action and control data, which is expensive to capture. With blueprints built on NVIDIA Omniverse and Cosmos, developers can generate massive amounts of diverse, synthetic data for training robot policies. First, in Omniverse, developers aggregate real-world sensor or demonstration data according to their different domains, robots, and tasks. Then use Omniverse to condition Cosmos, multiplying the original captures into large volumes of photoreal, diverse data. Developers use Isaac Lab to post-train the robot policies with the augmented dataset. And let the robots learn new skills by cloning behaviors through imitation learning, or through trial and error, with reinforcement learning AI feedback. Practicing in a lab is different than the real world. New policies need to be field tested. Developers use Omniverse for software and hardware in the loop testing, simulating the policies in a digital twin with real-world environmental dynamics, with domain randomization, physics feedback, and high-fidelity sensor simulation. Real-world operations require multiple robots to work together. Mega, an Omniverse blueprint, lets developers test fleets of post-trained policies at scale. Here, Foxconn tests heterogeneous robots in a virtual NVIDIA Blackwell production facility. As the robot brains execute their missions, they perceive the results of their actions through sensor simulation, then plan their next action. Mega lets developers test many robot policies, enabling the robots to work as a system, whether for spatial reasoning, navigation, mobility, or dexterity. Amazing things are born in simulation. Today, we're introducing NVIDIA Isaac GR00T N1. GR00T N1 is a generalist foundation model for humanoid robots. It's built on the foundations of synthetic data generation and learning in simulation. GR00T N1 features a dual system architecture for thinking fast and slow, inspired by principles of human cognitive processing. The slow thinking system lets the robot perceive and reason about its environment and instructions, and plan the right actions to take. The fast thinking system translates the plan into precise and continuous robot actions. GR00T N1's generalization lets robots manipulate common objects with ease and execute multi-step sequences collaboratively. And with this entire pipeline of synthetic data generation and robot learning, humanoid robot developers can post-train GR00T N1 across multiple embodiments and tasks across many environments. Around the world, in every industry, developers are using NVIDIA's 3 computers to build the next generation of embodied AI.
Physical AI and robotics are moving so fast. Everybody pay attention to this space. This could very well likely be the largest industry of all. At its core, we have the same challenges. As I mentioned before, there are three that we focus on. They are rather systematic. One, how do you solve the data problem? How, where do you create the data necessary to train the AI? Two, what's the model architecture? And then three, what's the scaling laws? How can we scale either the data, the compute, or both, so that we can make AIs smarter and smarter and smarter? How do we scale? And those fundamental problems exist in robotics as well. In robotics, we created a system called Omniverse. It's our operating system for physical AIs. You've heard me talk about Omniverse for a long time. We added two technologies to it. Today I'm going to show you two things. One of them is so that we could scale AI with generative capabilities. A generative model that understands the physical world. We call it Cosmos. Using Omniverse to condition Cosmos, and using Cosmos to generate an infinite number of environments allows us to create data that is grounded, controlled by us, and yet be systematically infinite at the same time. Okay, so you see Omniverse, we used candy colors to give you an example of us controlling the robot in the scenario perfectly, and yet Cosmos can create all these virtual environments. The second thing, just as we were talking about earlier, one of the incredible scaling capabilities of language models today is reinforcement learning, verifiable rewards. The question is, what's the verifiable rewards in robotics? And as we know very well, it's the laws of physics. Verifiable physics rewards. And so we need an incredible physics engine. Well, most physics engines have been designed for a variety of reasons. They could be designed because we want to use it for large machineries, or maybe we design it for virtual worlds, video games and such. But we need a physics engine that is designed for very fine-grained, rigid and soft bodies, designed for being able to train tactile feedback and fine motor skills and actuator controls. We need it to be GPU accelerated so that these virtual worlds could live in super linear time, super real time, and train these AI models incredibly fast. And we need it to be integrated harmoniously into a framework that is used by roboticists all over the world, Mujoko. And so today we're announcing something really, really special. It is a partnership of three companies: DeepMind, Disney Research, and Nvidia, and we call it Newton. Let's take a look at Newton. Thank you. All right, let's start that over, shall we? Let's not ruin it for them. Hang on a second. Somebody talk to me. I need feedback. What happened? I just need a human to talk to. Come on, that's a good joke. Give me a human to talk to. Janine, I know it's not your fault, but talk to me. We just got 2 minutes left.
I'm right here. They're re-racking it.
They're re-racking it? I don't even know what that means. Okay. Tell me that wasn't amazing. Hey, Blue. How are you doing? How do you like your new physics engine? You like it, huh? Yeah, I bet. I know. Tactile feedback, rigid body, soft body simulation, super real time. Can you imagine just now what you were looking at is complete real-time simulation? This is how we're going to train robots in the future. Just so you know, Blue has 2 computers, 2 NVIDIA computers inside. Look how smart you are. Yes, you're smart. Okay. All right. Hey, Blue, listen. How about let's take them home? Let's finish this keynote. It's lunchtime. Are you ready? Let's finish it up. We have another announcement. You're good. You're good. Just stand right here. Stand right here. Stand right here. All right, good. Right there. That's good. All right, stand. Okay, we have another amazing news. I told you the progress of our robotics has been making enormous progress. And today we're announcing that GR00T N1 is open sourced. I want to thank all of you to come to let's wrap up. I want to thank all of you for coming to GTC. We talked about several things. One, Blackwell is in full production, and the ramp is incredible. Customer demand is incredible, and for good reason, because there's an inflection point in AI. The amount of computation we have to do in AI is so much greater as a result of reasoning AI and the training of reasoning AI systems and agentic systems. Second, Blackwell NVLink 72 with Dynamo is 40 times the performance, AI factory performance of Hopper. And inference is going to be one of the most important workloads in the next decade as we scale out AI. Third, we have an annual rhythm of roadmaps that has been laid out for you so that you could plan your AI infrastructure. And then we have 3 AI infrastructures we're building. AI infrastructure for the cloud, AI infrastructure for enterprise, and AI infrastructure for robots. We have one more treat for you. Play it. Thank you, everybody. Thank you for all the partners that made this video possible. Thank you, everybody that made this video possible. Have a great GTC. Thank you. Hey, Blue. Let's go home. Good job. Good little man. Thank you. I love you too. Thank you.